Okay, so what we're going to do now is talk about how Java streams compares and contrasts with Java collections. I'm going to assume that you know something about what Java collections are, and we'll talk about how collections and streams work with each other. They have a very nice synergistic relationship that we're going to cover here. So you'll see that there's a whole bunch of libraries that are known as Java collections. They include things you're familiar with, undoubtedly, like ArrayList, HashMap, set, and so on, tree set, hash set, and so on and so forth. And so we'll talk about how streams compare and contrast to that. Now, first of all, there's something else, just to be confusing, there's something else in Java called a stream, and they talk about Java I/O streams. And so when you first hear about Java 8 streams, people sometimes think, oh, that's some variation on I/O streams. And of course, they're not really related directly at all, although later versions of Java I/O streams have been integrated to some extent with Java 8 streams or Java streams. Very confusing terminology. So if you take a look, you can see that a stream is basically a way of being able to get data from some data source, which would be something like a file, most typically, and being able to read that into your program, and then being able to take your program and write stuff out to the data source. So that's what a Java I/O stream is. And even though they use the same name, the mechanisms are really quite different. Probably the easiest way to think about the difference is that I/O streams are typically about communicating with persistent entities like files, whereas, as we had talked about the other day, Java 8 streams are really about transient flow of data in memory. So that's sort of one way to differentiate them, but they're not the same thing. However, you can use them together. In fact, there's methods that exist on the Java I/O classes that are used to read the data back and forth. More interestingly is the relationship between Java collections and Java streams. And there's even more of a tight coupling in some ways, or at least a conversion-oriented mechanism between collections and streams. So collections, of course, would be things like ArrayList. And as you can see in this particular case, these are very familiar to you. Hopefully, we're implementing stuff that's very much like this as part of assignment number 1. So what is a Java collection? A Java collection is an in-memory data structure that can be used to store, retrieve, manipulate, and so on, groups of elements or collections of elements. And the ArrayList is a good example of this. You have Java util ArrayList. It's got a size. It has some kind of backing store, like a built-in array, and it contains element data. And obviously, the size indicates how much of the elements in the element data have are relevant for the operations you're trying to perform. And then each of the entities in an array list is actually a reference to some other object. So we might have an array list of points or an array list of employee records or who knows what. But that basically allows you to do operations on the array list. By the way, just one little side note in looking at the programming assignment solutions, make sure that when you're doing iterators, especially with respect to the for each method, that you're iterating through the object, not the M element data, because M element data is the underlying buffer, the built-in array that stores the elements of type T, and you don't want to be iterating over that. You only want to be iterating over the part that actually is relevant to what has got valid data in the array. So don't be doing a for each loop through M element data for the for each method. That'll get you into trouble. Even though it'll compile, you'll get strange results. So you can kind of think of a collection as something analogous, that's not quite a perfect analogy for obvious reasons, analogous to a DVD, in the sense that the data is all stored in the DVD. And all the contents exist statically. Now, the reason that an in-memory collection, the reason why a collection is not like a DVD, of course, is a DVD is persistent. If your power goes off, your DVD should still hold the contents of whatever multimedia files you've got on there. And a collection is not like that. But the basic idea is that it all exists statically. So that's kind of the way to think about it. Conversely, a stream is a fixed data structure that will be used to process elements on demand. And by fixed data structure, what we mean is that there's a certain number of aggregate operations that are chained together, and the elements that are chained together are known when the stream starts to run. We know what's in the stream. And you can use a stream, as we talked about before, to kind of chain together this pipeline set of elements, pipeline set of operations, applying behaviors or functions to each one. And the stream can be used to manipulate elements obtained from a collection without having to explicitly iterate over them. The stream will provide the information from a source, you do some transformations, and when you're done, it can do something. It can write it to the output, it can put it in another collection, it can do whatever you want it to do. So you can kind of think of a Java stream as being something analogous to a flow of bytes in a streaming video, where at least conceptually it could keep flowing, as opposed to having things have a fixed size. So the content in a stream, just like the content in a streaming video, is dynamically received and processed in some way. So those are the analogies. Again, they're not perfect analogies. They're just there to kind of help you orient your head around collection equals something that kind of exists statically, whereas a stream is something that's going to be received and processed dynamically. There are a wide variety of factory methods that can be used to convert collections to streams and vice versa. So we've talked about many of these already, just a quick recap. So if you have some kind of collection, like a list or an array list, then you can convert that into a stream by saying .stream. You can convert it into a parallel stream by saying .parallel stream, and that goes from the collection representation into something that can be manipulated by composing the functions together via aggregate operations. And then when you're all done, you can collect the results and convert it back into something. You can convert it back into some kind of collection. And we'll talk about a whole range of ways of doing that. There's a wide variety of ways of collecting things together and reducing the stream elements into something that's got a fixed size. Okay, so here's a simple example of manipulating a Java collection. So we're going to have a bunch of arrays, and let's say, for sake of argument, that they have some prefix or some suffix that's not what we want. They have something that's not what we're looking for. And so what we're going to do here is we're going to create a list from this array, and then we're going to iterate through the list for I equals 0, I equals urls.size. So that obviously would be 3 for this particular case. And every time through the loop, we're going to set the ith element of the URLs list to be the current element where we replace this substring with that substring. So just kind of illustrating how you can have an array that manipulates, you can manipulate something that starts in an array, goes into a list, then you update the list, and you end up with a result that will be the modification to those elements. Here's the same approach, except this time we're using a stream as opposed to using a loop. So once again, we've got the same input, except this time we say convert this URL array into a stream, and we're going to use the of factory method. We've looked at of before. We'll see of a lot of times. And that will essentially it'll convert the array, the built-in array, into a stream, and then we're going to transform each element in the stream. So for each element in the stream, each element s, which is a string in the stream, we're going to replace the substring cse.wustel with dre.vanderbilt, and then that will generate an updated string as output. And then we're going to go ahead and collect all those results together by using this terminal operation called collect. We'll talk a lot more about collect later. You've got a chance to play around with collect shortly. And we will convert the stream into a list, and then we will collect it into the URLs list variable. And so, why is this cool? This is cool. This is cooler than this for a whole variety of reasons, not the least of which is we don't have to have a range-based for loop, so off by one errors are not going to occur. And number two, we don't have to remember to initialize things, and everything's done in a more implicit way And of course, as we also talked about, we can speed things up very nicely by being able to parallelize this if we need to. Obviously, for 3 elements in an array, it's probably overkill to try to parallelize it, but the point still holds. If we had a very large list of URLs, we could actually get a good speed up for that. Keep in mind, as we had talked about earlier, that elements in a stream can only be visited once during their lifetime. So we can't go ahead and try to redo this thing without generating the stream again from the array. So the key to the power of streams is their ability to chain transformations. So you'll see, here's a simple example of this. So in this case, we ended up with a list of strings. But what if we wanted to end up with a list of URLs? So what we could do in that particular case is we could change string to URL, and then we would simply find a way to map the string that comes out of this map operation. So this map operation here that does the replacement generates a stream of strings. And then we go ahead and we map that stream of strings into something that will create a stream of URLs. And in this case, we're going to pass in the URL new constructor reference. That's called a constructor reference. And that will take a string and return a URL as output. And kind of as we talked about before, we can make this thing a little bit cleaner. We might want to use some kind of adapter that converts a constructor that was designed to throw or specified to throw an exception of some kind into something that will have no exception in its signature. So that converts a so-called checked exception into a runtime exception. You can read more about the mechanism behind that here. It's really cool and makes the streams a lot less verbose and a lot easier to work with. Okay, so any questions about that? The basic point of this video is just to say that streams and collections have synergies with each other. You can convert collections into streams, manipulate stuff, compose things together without having to use explicit looping and so on, and control flow constructs. And then you can convert them back into collections when you're done, if that's what you need to do for whatever purposes you're implementing that program.